This is Exploring Elm's Compiler Error Messages. I'm Nick Sharma. You can find this presentation up on the GitHub repo in the link, which you can also click and then watch the slides in case you don't want to watch me talk right now, so that's an option that you had at the time. So I'm going to tell you a story about how I got interested in this topic, like why the error messages were compelling to me, and then I'm going to dive into all the different kinds of error messages you can get. And Richard just showed us some great ways that you can write Elm code, and hopefully a lot of other people will be showing you today good patterns and good code that you can write. I'm going to show you a bunch of terrible code that doesn't compile at all. So please don't copy any of this in production or anything, but I think it's just fun to look at. And so first of all, I just want to give credit where credit is due. So I built this presentation itself in Elm using a package called Elm Slides by XR. I determined all the types of errors by reading the compiler directly. So of course, Evan and everyone else who contributed to that. And a lot of the code examples come from a repository called the Error Message Catalog, which exists to showcase different Elm code blocks that can trigger different errors in the compiler. It was started a few years back and has some minimal examples around type errors and things of that nature. So I actually have a fork of this right now that's a bit more filled out. So some of the examples that I will show you today are things that I wrote versus things that others have written in the past. So like Alex mentioned, I do some hobby development for a group called Anime Chicago, which is a meetup group for anime. So if you're local and that's your jam, feel free to check us out. We're on meetup.com, and we have a website, animechicago.com. And one of the projects that I did for them was building a little quiz questionnaire that you can go and figure out what to watch if you're undecided. And so I can show that off. So it's at bot.animechicago.com. So if you are looking for something entertaining, maybe we want an action series. I want it to have an ending. And of course, we like giant robots, so you should watch your one. And that's the entire thing. So it's a very simple application, but the idea is that instead of hard coding all of the different shows in, we have a data structure, which is the questions that you can have at any given level. And then when you answer a question, you might get more questions, or you might terminate and get an actual recommendation. So I wrote that as one of my first Elm projects, and I had a lot of fun with it. But one of the challenges I had early on was I got into this situation. Has anyone ever seen this error message before? Okay, a lot of people have. So I'm glad that I'm not the only one, because when I saw it, I felt like I am done with programming. I'm going to go sit in the corner and ponder my life choices. And so I saw this, and I just felt very bad about myself. And this was basically my reaction. I was just very confused. But then a really interesting thing happened. I looked at the error message again, and it was actually pretty readable. And there's this thing at the bottom that says, hints. There's maybe a typo in a variable name, but there's also this article that you should go read, and maybe it'll give you some insight. So I went to the article that it suggested, and it said, in this case, the trick is to use json.decode.lazy. And I tried it out, and it worked. Wow, how often does that happen? So that was kind of the light bulb moment for me. That was wow, Elm is a really cool language, and maybe there's something to this idea of trying to have really good, really intuitive error messages that can guide you. So these are all the types of error messages that are representable in Elm. We have syntax errors, which also include all of parsing errors, canonicalize errors, which, as far as I can tell, is just making sure that even if your program is syntactically valid, that things still make sense and it can be interpreted. Type errors, which I'm sure you've seen before. Main errors, which are reserved for the main function. pattern errors for your pattern matches, and docs errors, which is a really cool type of error that I didn't know about, that it even existed until I started doing research for this topic. So who has actually written an Elm package and needed to provide documentation for that here? Okay, so then you've probably seen this, or at least have tried this. But for everyone else, this is a special type of error that you can only see when you're trying to compile your Elm program and create documentation for it. So I'm just going to go through a bunch of code. It's going to be a little bit of a whirlwind, but I'll try to keep it pretty simple. So first of all, the syntax errors. I'll have about like 2 to 4 examples per category, but there are generally many more types of errors that you can get. So if you're interested in this topic, I highly encourage you to check out the error message catalog that I mentioned. So this is the first one. If you define a function but don't implement it, this is a syntax error. So it's pretty basic. It's hard to run into by accident, but when I'm developing, a lot of times I just write out the types first to crystallize what I want to do. So I actually run into this. So Elm has authoritatively decided that tabs versus spaces holy war, spaces is one. So actually using a tab in a file is a syntax error. So this one I actually think is pretty interesting. If you try to pattern match on a float value, this is a syntax error. So of course, if you have a float value, what you really want to do is compare it using some small difference, like an epsilon. But what is also kind of noteworthy about this is that a lot of other languages with case statements or switch statements will happily allow this. So JS allows this if you did like the equivalent code block. But in Elm, it's a syntax error, which I think is great. And then if you have a shader expression, which is this thing that starts out with GLSL vertical bar, and you don't terminate it, then that's a syntax error. So when I saw that, my first reaction was, that's cool. My second reaction was, well, it's a shader. I've seen this before. And so it turns out that Elm has embedded an entirely separate programming language into these specific types of expressions. So it's called the OpenGL shading language, and you use it for graphical things and trying to turn meshes into actual representable graphics. And so when you open up a shader expression like this, you can see you can enter in more lines for actual shader program code, and then you terminate it by basically another vertical bar and ending the bracket. And then you can use that, and Elm can even type check it for you. So I think that's pretty cool. I work on backend stuff most of the time, so I've never seen anything like this. And I don't really like the blue angry box there. So, so that's it for the syntax errors that I'll show. For canonicalized errors, so these I think are a bit easier to run into because even if you are confident in the syntax of the language, you might get into a weird situation. So first of all, if we have a custom type, you cannot define the same named constructor more than once. So here we have foo, and that just, you can't do that. All right. Who's run into this situation before, where you have a record type and then one of its members is trying to recurse on it? So this is another type of canonicalization error that you can get. And one of the approaches that Elm recommends is to have another type for the type that you're recursing on. So I also got into this early on and had to refactor things around. And then this is the code that I wrote to get that original error message that we saw. So in my structure, I have a tree which can either have a question or a recommendation, and then your questions lead to more of those. So this was a thing that I would have not known to resolve without the article, and so I'm really glad that the error message was able to point me in that direction. And it comes up pretty frequently when decoding. So for type errors, they're actually, this is one of the richest categories of errors that you can get in Elm. There are about 3 building blocks for the various type errors that you can get, but you can apply them in multiple ways, and I'll show you a couple of examples of that. So first of all, if you have an if expression, both branches must return the same type. So if you're coming from an imperative language where you have an if statement, this might be a little alien to you because you might just use if some condition do something, and you wouldn't think about the else case, or you might even do a completely separate thing in the else case. But in Elm, it is an expression, and it has to be consistent between both branches, which type it is returning. Another thing that it will do is it will enforce that you call a function in the Elm way, which is with spaces and kind of an ML style of calling a function. If you try the C style, which is like open paren, close paren, and commas separating your arguments, it would think that what you're trying to pass into, in this case, this function iterate, is a tuple. And that's not the arguments that the function is declared. So this is also not type check. And then this is a really basic example of mismatching in subtypes. So here we have a tuple of a string and an int, or compared against a string and a maybe of something. And of course that doesn't type check. But what's also true is if you are, if you have any essentially container data type, like a list or a dictionary or something like that, and the constituents do not match up, then it will also give you a subtype mismatch. So there are a lot more concrete examples of this in the error message catalog that go into if you have a dictionary or a list. I just chose the tuple one for brevity. So then main errors, there are only a couple of these, and these are reserved for the main function. So first of all, you have to have something that's actually a legitimate main value, so like browser.element or beginner program or something of that nature. So if you just put an int or a string or something like that, this does not work. But what's also true is that it enforces that main does not use recursion to compute itself. So your main has to be a simple declarative value. I think that's kind of valuable because you might be tempted to write main in a very complex way. And this is the compiler telling you, please keep it simple. It will make everyone's lives easier. Okay, so pattern errors. We saw during the last talk that when we add a new case, Elm will let you know that you aren't covering all the cases if you're matching off of the custom type. What I didn't know before this, doing this research is that it will also tell you that if you have redundantly matched on a case, that this is also an error. And again, this is something that isn't typically found in other languages with case or switch statements. So in JS, I could write a second switch with as, and maybe that one actually has the branch that I actually want to execute, but it'll execute the first one in order and not really warn me about it. So I think this is, you probably won't run into it accidentally, but I think it's still kind of cool. And finally, we have the errors for documentation, which, like I mentioned, have a couple of prerequisites. So first of all, you have to be writing a package, and that requires specific attributes in your Elm.json. You have to declare it as a package, and you actually have to list the modules in your that you have that you want to be exposed. And then when you call Elm8, you have to supply the docs flag and specify the docs file that you're writing to. So if you do this, then it will potentially throw compiler errors for your documentation. But if you don't, then it will just successfully compile it because you're just trying to run it or do whatever else. So first of all, if you are trying to provide a package and you don't write any docs, then why would you put that on people? So it will stop you from doing that. But what I thought was really interesting here is that in most applications that you write, you can write a module that exposes everything. But when you are writing a package for others to consume, the compiler forces you to take care and it whitelist all of the things that you want to be public facing. And in the error message, it will tell you that this is something that they're trying to help people design better APIs. So I think that's a great feature. It's something that helps package authors and helps the community and raises the quality of packages that are being published. If you declare something that is exposed but isn't documented, or you document something that is not exposed, this is also an error. And if you have your object in there, but you either do not have type annotation or a documentation comments, you're also not allowed to do that. And so just to be clear, there's two levels of documentation going on. There's the documentation for the module with the app docs attribute, and then the documentation per object that you're exposing. So that's pretty much all there is for the content of this talk, and I had a couple of good learning experiences from it. One is that I just had a lot of fun reading the Elm compiler code. So when I started this, I'm like, okay, it seems like a good, intro level talk for, first time talk and everything. And then I realized I'm going to read through this Pascal code base and just try to figure things out. And it works out just fine. So I thought it was good, and I was able to understand things pretty well. I think that also generally speaks to the readability of the code base. But the other thing that I think is great is that the API design, and in this case I'm thinking of the error system as an API, where you supply code and you either get a valid working program or compiler error messages. And it's not only about making sure that your program is syntactically valid, but also making sure that you're doing things well. For instance, in the pattern matching, that you're not trying to pattern match on a float and do a comparison that might fail, or when you're designing your API for your documentation, that you're actually thinking carefully about what your public API should look like. So I think this is a good example of how careful design of an API can make your users better and empower them. And that is everything, so thank you for attending.